Hello class, this is Craig, and today I decided to make you a video to give you a little bit of help with your critical thinking 5 work. Things are getting a little bit tougher and we're entering into an area of inferential statistics where, yeah, it's getting a little bit tougher. Okay, the topic this week is confidence intervals, and I've drawn poorly a normal distribution. A normal distribution looks like this. We know that many things in the world follow normal distributions. Many things from the biological sciences, the height of people, the diameter of trees, the strength of ants, you name it. There's tons of things that follow this normal distribution. What else do we know? The mean, and this is, I think this letter is mu. Can't remember, but it means population mean. We know that the population mean is at the center of the distribution. We also know that the mode and the median are equal to the mean, so they're all lined up right in the center in a normal distribution. We also know something about how many values fall within here, and if we went out, let's see, 2 standard deviations on each side, come on pen, we would find that 95.4% of the values, 95, let's just call it 95%, fall within plus or minus 2 standard deviations. Okay, so let's jump back to confidence interval. What is a confidence interval? Well, let's put some real numbers here, and let's say that this was equal to 10, a population standard deviation of some population. Well, what if I went out and took samples from the population? And let's say I took, oh, I don't know, 20 items multiple times. Well, one time I might find a value out here. I might find, whoopsie, we don't want to do that, not 9. Let's call it 11. We might find a mean. Come on, pen, why are you doing this? Oh, because I'm on the eraser, that's why. We might find a mean of 11. Another time, we might find a mean of, let's see, that's 1. This would be about 9. And another time, you know, it's just random samples. We might find that this is, let's say, 7 over here. Now, what a confidence interval is a statement that says we are guessing that the mean is equal to this value, and 95% of the time, the confidence interval I build will cover the true mean. So what I'm going to do is put some parentheses around this, and I'm going to call this my confidence interval on my sample that gave me a mean of 11. Well, does this one cover the true mean of 10, the population mean? Yes, it does. How about this one of, we haven't talked about how to calculate these bounds yet, but we're going to. Does this one cover the true mean? Well, sure enough, it does. And in fact, if we're calculating a 95% confidence interval, let's see, 19 out of 20 times, we are going to find that a similarly constructed confidence interval covers the true mean. How about this one? Well, let's do this. Here's his confidence interval. Uh-oh, this one did not cover the true mean. Yep, that's the 1 out of 20 that does not cover the 5% that we're going to get wrong. And some people like to use the statement that when you construct a confidence interval that you are 95% confident that this interval contains the true mean. And we use that statement a lot, but it's really not quite statistically true. What we should say is that we are 95% confident that similarly constructed intervals will contain the true mean. It's a very slight difference, and truthfully, I don't even care which you say, but that's what statisticians like to say. Okay, so how do we calculate these confidence intervals? First of all, if we know the population standard deviation, and there's the population standard deviation. If it's known, population standard deviation, then we can calculate a confidence interval like this. It's equal to x bar plus or minus the z statistic at alpha over 2 times population standard deviation divided by the square root of n, the sample size. N, the sample size. Why does that sound funny to me? No, that's correct. We pull a sample, we calculate the mean, we look up this value in a table, and it's a description. It's the z value. It describes the probabilities of reaching a certain value of z for various alpha levels. And let's see, where in our textbook is this table? Well, the inside cover has one. I know that does. Mine's kind of pasted in there. Yep, probabilities, a standard normal distribution. And, okay, why alpha over 2? Well, it's because this. If we're constructing a 95% confidence interval, that means that we have 0. I lost my pen again. 0. Oh, I screwed it up again. 0.025 in this end, and we have 0.025 on that. And you add these three numbers together, 0.025, 95%, and 0.025, and you get 100%. So that's why if our confidence interval is a 95% interval, then alpha equals 0.05. And when we go to look up a z value, we have to, this is the picture we're looking up, we want 0.025 in each end, so we have to look up z alpha over 2. Okay, now that's if the population standard deviation is known. What if it's unknown? Then we are going to use S, the sample standard deviation. This is a much more common case. How often do we know the actual standard deviation of an entire population? It's quite rare. Textbook example is always, maybe you have a machine in an industry and you've been measuring its output for 30 years and you know very well how much it varies. Well, that might be an example where the population standard deviation is known, but it's usually not. And so what do we use? We use the sampled standard deviation. Again, we're going to calculate x bar. We're going to add not from the z distribution, but from the t distribution. Again, at alpha over 2 times not the population standard deviation, but the sample standard deviation, again divided by the square root of sample size. This is the equation we will use, and this defines our confidence interval. However, there's one problem. I made one mistake here. Do you see it? Yeah, it's right here. It's not just plus, it's plus and minus that value. So we're going to have the mean plus a certain amount on one end. So that's stretching to, plus is stretching to one end of the confidence interval. And the mean minus this quantity is stretching to the other end of the interval. Okay. So let's jump over now to my spreadsheet, and I'll show you an example. A lot of the stuff we can ignore for now, but concentrate on this left-hand side. I went out and measured the shoe size of a bunch of people, and I think there's 29 of them here. And what I want to do is calculate this confidence interval for the population mean, and I'm going to do a 95% confidence interval. First of all, we need what's called a point estimate, and that's our best estimate of what the mean is. And if I click on that cell, you can see I'm just calculating the average or the mean of those 29 values between A7 and A35. And, well, the count function, whoopsie, works for that well. It'll tell us how many are in there. Degrees of freedom is something I didn't talk about. When we use the t distribution and we look up values in the back of our book, there's Appendix A, I believe it is, you will find that you need to know the alpha level, actually the alpha over 2 level. Oh, looks like I have a mistake here. Let me go in here and fix this if I can quick. This should be T at alpha over 2 equaling 0.025. All right, so let's see, my point is, all right, yes, degrees of freedom. Degrees of freedom are equal to n minus 1, and when you look values up in a t-table, you will use 28 for degrees of freedom. Confidence level, yes, 95%. Difference between that and 1 is alpha. That is our alpha level. And again, since I showed you and talked about how we're looking at two tails in that normal distribution, we're going to be actually looking up the t level at alpha over 2. Not 0.25, Craig, it's 0.025. Boy, get it straight. Dude, there we go. That's better. Okay. So now, back, where were we? Sample standard deviation. There's my equation for it. STDEV.S gives us the sample standard deviation. And now the 2.048, you can see there's no equation. I just went in and looked that value up in a table. And you can do that too, and the book tells us how to do that. Margin of error. Now this is the value that is the plus or minus. And I did it two ways here. The first way is using our calculation, and it's that equation that I showed you before. It's this one right here. I'm looking at this portion, and so all I do is take my t-value, multiply by the sample standard deviation, and divide by the square root of n. And when I do that, I get, let's see, did I do that? 2.048 times, let's see, times d12. Yep, sample standard deviation, and divide by the square root sqrt function of sample size. And it gave me 0.5029. Now there's also a fancy function in Excel. It's the confidence.t function. And if we look at that, we simply need our alpha level, not the alpha over 2. I put in D11, 0.05. D11, 0.05, yep. Standard deviation, I had to point to that, my 1.32. And sample size, not degrees of freedom, which is sample size minus 1, but the actual sample size, 29. And the formula gives me the same result, 0.503. Oh, those are real close. All right, then to calculate my confidence interval, I'm simply going to take my point estimate, x bar, plus this value, and for the lower confidence level, let's see, say that again. X bar minus the margin of error will be the lower confidence. X bar plus the margin of error will be the upper confidence level. Don't worry about maximum error. Okay, did I do that? Yes, certainly. D7 minus 16. D7, I took the mean and subtracted that margin of error to get. So there's my confidence interval. I would suspect that 95% of the confidence intervals I construct are going to contain the mean. 95% of similarly constructed confidence intervals will contain the true value of the mean. We don't know what the true value is, do we? No, we just have a sample. Okay, we don't have to do it in our CT work, but I did something similar here for confidence interval of a proportion. We do things a little bit differently, but it's very similar. And finally, something you'll be interested over on the right here, I used our descriptive statistics to generate these data. And when I did that, we've used this before, data analysis, descriptive statistics. What I did was, there, I checked this box as well to give me the confidence level. And I put in 95%. We hadn't touched that one before. And when I did that, I got this bottom line here. Bottom line that said confidence level, 95%, is 0.5030. Well, look at, there's the 0.5030. So if you don't want to, you don't even have to go through these calculations. There's the margin of error. It's called confidence level, but it's really the margin of error. It's the plus or minus thing that follows the plus or minus in our equation. All right, I think I'm going to stop there for now. I hope this example has been of help to you in tackling CT5.